I'm Sophia, and I'm an infectious disease scientist in San Diego, California. I wanted to answer Ulrike's excellent question about why airplanes can fly despite their size and weight. Although I am not a physicist, I am a pilot, and I have taken flight lessons, so this is one of the first things you actually learn about planes during that process of getting your pilot's license. So if you think about airplanes can fly for the exact same reason that you can see birds soaring in the sky. The shape of the wing of an airplane is much like that of a bird's wing, with a slight curve up top. And what this does is that air actually moves faster over the top of the wing of the plane compared to the bottom. As air moves faster over a curved surface, what happens is that you have a resulting decrease in pressure between the top of the wing and the bottom of the wing. And this results in a force on the wing that actually lifts the wing up into the air. This force is called lift, and it's important to note that lift is actually only generated when the wing is moving forward, which is why you see airplanes must accelerate down a runway prior to flying to pick up speed, and also why birds must flap their wings to get up to speed to allow them to actually soar in the air. And this is prior to gliding, soaring, any of those activities. You think about speed has to be a factor there to actually generate that lift over the wing. So this principle of flight actually applies to both small birds and giant jumbo jets. It's the same principle. It's just that the jet will require something like an incredibly large jet engine to move the plane forward fast enough to generate enough lift to counteract the weight of the plane and other factor gravity impacting that plane and keeping it from plummeting downwards. So the jet engines would then allow the plane to move forward fast enough to generate enough lift to raise it into the air and fly. So I hope this helps you to answer that question.
Hello, my name is Dr. Carl and I am a postdoctoral researcher at UC San Diego. I have a PhD in plant biology, so I was very excited to see a plant question coming from Jesse Cunningham's first grade class at Chaparral Elementary in San Diego, California. There, Pema says that they would like to learn more about how plants suck up water. You may be surprised to learn this, but plants actually have structures very similar to veins. But instead of carrying blood, they carry water up from the roots to the leaves, and sugary water, also called sap, from the leaves down to the roots. Unlike veins, however, plants are able to move this water around without something like a heart that animals have. They can do this because water is a very special little molecule. One of the ways that it's special is that, as far as molecules go, it's actually pretty sticky. Water molecules love to hold onto each other as well as surfaces. In the plant, very thin veins called xylem go up from the roots all the way to the leaves. At the leaf, water molecules evaporate through little holes in their surface. As each water molecule leaves, it tugs a little bit on the water molecule in the xylem behind it. That molecule then tugs on the one behind it, that one tugs on the one behind it, all the way down to the roots. This is actually sort of like when you pull tissues out of a tissue box. When you pull the top one out, it's holding on to the one behind it, holding it up. And so you can imagine that as each water molecule leaves the leaf, it's pulling on the water molecule behind it, sort of pulling on this very long chain of water molecules all the way down to the roots. So in this way, plants are able to suck water up from the soil into their leaves or flowers and then out into the air. I really hope this helps answer your question, and keep them coming.